Okay, so we've seen now completing the square in sort of an unusual place. Normally we had used it to solve equations, and now it's just helping us get these kind of funky equations in x and y to be in the standard format for a circle. The next things we're going to look at are not going to be circles at all, but they didn't really merit having their own days worth of material. So we're going to complete the square in a rather new setting, and things are going to look a little different, just to be really honest with you. So the question is to rewrite x squared plus 6x plus 20 in this format, x plus h quantity squared plus k. Now I know this looks strange, but just work with me for a second here. What we're going to do is we're going to complete the square, and we've only done that in equations, whether it was to solve for x or whether it was in creating an equation for a circle. But now we're going to do this on an expression. Okay, we've only done this on equations so far, but we'll look at the expression x squared plus 6x plus 20, and we're going to complete the square. But there aren't two sides. Normally we add the same number to both sides, but now there's only one side in a sense. So we're going to add and subtract the number on the one side. So take x squared plus 6x plus 20. I'm going to suggest that we actually just take a line where we write essentially the same thing, just leave a little bit of space. The plus 20 is pushed way off to the side just because it's visually in the way, so we just kind of want it as far away as possible, but we still need to write the plus 20 to keep the equals. Take a look at that 6. That 6 is the linear coefficient, so half of that, 3 is the second stick. Square that number, 9 is the constant to add, but we can't just add 9. In order to keep equals, we have to subtract 9 as well. So we have x squared plus 6x plus 9 minus 9 plus 20. By adding 9 and subtracting 9, we haven't changed the value. And then the first three terms, let's organize just a little bit. Leave the first three terms, but then the last two terms, negative 9 plus 20, just write as 11. And then just keep that plus 11, but in the first three terms, we have x squared plus 6x plus 9. That you can factor and write x plus 3 quantity squared. Okay, so that now really is in the form x plus h quantity squared plus k. So we have only one side, and so we added and subtracted 9 to keep the value of the expression equal. In the second to last step, the perfect square x squared plus 6x plus 9 was rewritten as x plus 3 quantity squared. Let's try this again. X squared plus 4x plus 1, let's write that in this format, the requested format. Again, I think the plus 1, good to just push that way off to the side. Take a look at that number 4. That's the linear coefficient. Second stick is 2. Square the number 2, and the constant we need is 4. But we should add that constant and subtract the constant. So you see a plus 4 and a minus 4. The first three terms factor. X squared plus 4x plus 4 becomes x plus 2 quantity squared. And then there's still a minus 4 plus 1, which we can write as a minus 3. So in this example, k is negative 3. Okay, for the interactive question, I would like you to start with the final line of the answer, x plus 2 quantity squared minus 3, and then show your work, expand and collect like terms and so on to simplify, and then show that this really is truly equal to x squared plus 4x plus 1, which is the original expression in the question. Okay, let's do another example. Rewrite x squared minus 10x plus 2 in the format. So push that plus 2 way off to the side so it doesn't visually get in the way. Now, that number negative 10 is the linear coefficient, so negative 5 is the second stick. If you square negative 5, that would be the number positive 25. Now, I want to add 25 to both sides, but there aren't two sides to speak of. So on this one side, we'll add 25 and subtract 25. The first three terms will factor as x minus 5 quantity squared, and then the last two terms of negative 25 plus 2 can be written as a negative 23.